This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay. Hello. Okay, hello. Okay, so we're recording. Today's lesson we're going to be talking about code quality. Obviously, code quality is an important facet for your project that will be due soon. So we will go into detail in that today. I'm hoping that we have plenty of time to do a toy project during the class time. And my screen's just gone off. Excuse me a second. But as I begin, actually, first of all, is it just me or is it really, really hot in here? I'm sweltering. Anyway, and another thing, a big apologies for the rain. It is my fault because I wore shorts on the weekend. So every time I wear shorts, it rains. So... Right, I'm just trying to get my screen working again. Okay, it's back on. There we are. So before we actually go on the code quality, I do want to give you some examples of the super class that we were finishing off last week. So we started discussing the super constructor and what it actually means. And if you remember last week, we were talking about having a base class or a parent class and a child class. And the child class was inheriting from the parent class. And the super construct mainly basically defines the parent of the child, not the grandparent or the grandchild, only one step back. So if you're a child class, if you're working in a child class, that child class can peek into the super class or the parent class to see what the parent class has available. But the main thing that you need to do with the super construct that is you have to use it in a constructor. It's called constructor chaining, and I'll give you an example of that now so that you understand how it works. To me, I found when I was originally learning Java, back in 1702, just kidding, I found the super construct sort of threw me, especially when I started working in graphics, because I didn't quite understand at the time. We weren't taught the super construct in how I'm going to teach you it today, hopefully. So it didn't really settle with me very well. So let me get rid of these. The example that I want to show you is, so if we have a parent class, which I have here. Oh, you can't see anything, guys. Oh my gosh, what the hell? You got to say something. I'm like, I can see everything here. Oh, dear Lord. Okay. Right. I am so sorry. So you're going to be watching this online now going, what? There's nothing on the screen. I'll just wait for this to wake up or something. I've asked it to do its thing. Is it coming on? Okay, let me just check that there's no disconnections, because that does happen from time to time. Nope, I'm being a doof. I just realized what I'm doing. I haven't even plugged it in. It's going to be one of those days, guys and gals. One of those days. Should we start again? Right. Can you see what I see? Good. Okay. My word. Okay. I hope this isn't a sign of things to come for me. Okay. So we're talking about the super constructor, right? And we were talking about inheritance last week. We were talking about abstract classes also. And a point one of your colleagues made at the end of the class, which I should have mentioned, was that of when you're inheriting from a parent, you can only inherit once. One class can only inherit from, I can't even say the word, inherit from one parent, right? So you can only inherit once. So you can only extend one class. But you can take as many as you want from the abstract classes. You can have as many abstract classes as you need, which we will go into more detail next week or the week after, I forget. So we're talking about constructor chaining. And constructor chaining basically is whereby if you're a child class, if you're working in a child class and you're inheriting from a parent's class, then the first thing you do in the constructor of the child is that you must initialize the constructor of the parent. So if the parent doesn't have a constructor, so if the parent has an empty constructor or a generic no constructor at all, this doesn't really matter. Java will automatically give you an empty constructor that you can utilize, or it will utilize an empty constructor for you, a super constructor. But in the example that I thought I was showing you, I thought it was really dark in here. Anyway, let me just make this a bit bigger. So here's a basic parent, a class called parents, which is acting as a base class, right? And I'm going to inherit this class as a child. So I've also got a child class here, which, as you can see, extends the parent. And as I mentioned last week, when a child class extends a parent class, it essentially adopts or has all the methods that are available to the parent class available to it. And if it doesn't like one of the methods within the parent class, it can override that class by naming it the same, giving it the same signature, and just giving it some new sort of new information, new sort of structure to work with, right? So what I've done is I've just created this really basic child class that extends a parent. The child has child variable 1 and child variable 2. And let me get rid of that for a second and focus on this one. The first thing I've got here is a child constructor, which, as you know, when you're creating an object, the constructor is called first. This constructor signature has 2 integer values, which are going to be catering for these 2 integer values of the child, right? And the first thing it has to do is call super, and the reason it has to do that is because the parent class has a constructor that also has values, right? So because this parent's constructor has 2 values, 2 integers, the first thing the child's constructor has to do is to give value to those, to the parent's constructor parameters. So in this case, it's just sending some variables to the parent, and that allows you to then utilize everything that the parent has to utilize. So if I go to this class here, so we've got 3 classes. We've got the parent class, which is an object of parent, a child class, which is just an object of child, and then I've got a main class, which I'm just calling inheritance main. And for inheritance main, I'm making a new child, and with that child then, if you remember, child only has 2 variables. I've left them as defaults. If you remember from last week, the defaults, I've just left them as defaults, so they're visible to this package. And we know that I've created a new child, therefore we know that I should be able to access these 2 variables, child variable 1 and child variable 2, simply by saying the name of the object that I've made. Oh my gosh. And then you can see child variable 1 is available and child variable 2 is available. And in addition, you can see that parent variable 1 and parent variable 2 is also available because we have, in the child class, because we have extended parents. So we're standing on the shoulders of the parents and we're able to use whatever the parent has taught us, and we can also overwrite those as well within the child, right? Does that make sense? So the key of what I'm really showcasing, or trying to showcase in this instance, is that the first thing that you have to do, if the class that you're inheriting, aka the parent class, has got a constructor that requires some values, aka a signature, then when you create the constructor for your child, which is inheriting from that parent, you must call super, which is kind of calling the constructor from the parent, and provide whatever the parent needs to be instantiated to make an object of that parent. Does that make sense? Any questions? No? Okay. Let me go back to the slides just so we keep on. Okay. So this is kind of just showing how to call the super constructor. That's what that's showcasing. And that's, so if your parent's constructor doesn't have a signature, doesn't have any values there, so there's no information required to construct an object of that parent, then you don't have to call super, because super will be called automatically. And the key for this is that, if I go back to the code, the key is that even if my constructor has to do a billion things, even if I have to dig a hole somewhere and provide some network information, doesn't matter what the constructor has to do, you have to call super first. The very first thing you do is call super. If you don't do that, then you'll get an error and it will crash, so it won't compile. The next thing is the this constructor. Now, this constructor sounds a bit odd, right? And the this constructor is saying that if you want to have, let me show you with an example. So I've got this constructor here. So my child constructor, my child object here, has got two constructors. The first constructor is an empty constructor, and the second constructor is a constructor that has two values. Now, in the first constructor here, I'm calling this, which is in fact calling this, right? So what's happening is this is calling its main constructor with this signature, and then the word this again, this actual constructor is then calling super. So even though I'm calling this, I'm actually calling super first, if that makes sense. Does that make sense to everyone? Have a play around with the construct of both super and this. If you don't, as I mentioned, if your parent doesn't have any values in its constructor, then you don't need to use super. If it does, then you will need to use super. And that's pretty much the overview of what we missed out really last week. There's a few more slides which I'll just rocket through. Do you have any questions on this? Pardon the pun. No? So this is just going on explaining default constructor chaining. So if I don't have, that's just reiterating what I've just told you, if the constructor doesn't have, it doesn't begin with super or doesn't begin with this, Java will automatically insert just this super in there for you, right? Which often isn't as useful. Oh, did I just jump? This super for you, which isn't as useful as controlling it yourself either. So that's pretty much what I was just covering. Another thing is if you don't extend a class, so if you look at the example here of parent, now parent isn't extending anything. And because parent isn't extending anything, and this applies to every class that you create, in such an instance, Java automatically, behind the scenes, extends object class, the object class, which gives you certain object utilities that you can use, such as the toString or the equals method. So these are inherited by all classes, and they're obviously available to you for whatever needs you have. So I will do a quick poll. So if you go on your quick poll, if you go onto this, and the reason I want to do this is because I want to ensure that I have covered it sufficiently to enable you to pass an exam question when that time comes. So if you go on your super devices, your brand new iPhone, does anyone got an iPhone 11? No? If you go on your iPhones, hey, well then, lucky. Go on your iPhones, your Androids, your Macs, your PCs, your laptops, your iPads, your whatever you have, any other tablets or such, and get ready to answer the following question. Overriding. Oh. If the base class S contains only one method with this header here, which of these definitions would not be allowed in the derived class? Let me just move this a little bit out of the way. Oops. There we are. So, if a class, which we're going to call S, contains only one method with this header, so that's a whole class, this is the method header, which of these definitions would not be allowed in a child class? If the parent has this method and the child has to override the method, which of these would not be allowed? Do you guys remember when we were talking about overriding and what is permitted and not permitted? So this is jogging back a whole week. I realise that you've done a lot of things in a week. I see a lot of scratching heads. Okay. So let's have a look on what you guys think. Hopefully there's more than just me. So I'm going to update. Right, so the majority say C, with a few saying D and E, and then sort of, yeah, a couple on A and B. Now then, which is it? It's actually B. So the 6 of you who said B, well done. And the reason for that is that we're saying is not, cannot, would not be allowed. Now public void foo int is actually an override, so that's allowed, right? Private void foo char is not an override, and you can't, if you remember, you can't change the visibility to be less. Do you remember that from last week? So C, you can't change the visibility to be less. Then obviously, because this is the right one, which is what you can't, sorry, you can do that because the char has changed, beg your pardon. So you can do it. You can't change the visibility, but you can change the signature, which doesn't override. So this particular line doesn't override. This one cannot be done because it's changing the visibility, and it's trying to override the signature, which can't be done. Okay? So for those of you who got C, that's the reason why, because I can see why you'd think C, but it isn't the case. And then obviously because this is the correct term, the others don't apply. Any questions? No? Okay. Another thing, when you're creating an instance of an object, you can use the instance of operator. This is very useful, the instance of operator. I use it immensely. And essentially, it's kind of saying like, look, I have a child, and I want to know if it's an instance of what. Because sometimes you want to have some code that's very compact. And when you have a very compact code, you might want to use an object within that code and just use the term object because you know it inherits that. And then you might want to do something different to an object if it's of a certain type. So you can ask if the code is an instance of some other code, you know, if it's an instance of a certain class, and if it is, you can act upon that. And again, that's something that's very, very useful. And again, it's a case of just putting the instantiated object, so the name of the variable of the object, the keyword instance of, and then you give it the class name that you want to check if it's an instance of that class. And that allows you to check to see whether certain values can be available or whether you can do something useful or different with a particular class of class type object without having known what it was first. So you can, you can not do stuff on a certain object if it isn't the object you're looking for, if that makes any sense at all. Any questions on that? No? Okay. So you also have a get class method, which you can call upon for every class. This is also inherited from the object class. And the get class, you can actually use the equals to. So if you want to compare two classes and see whether two objects are equal to each other, this is one case you can do that. Is if you call the get class first, and then it actually gets the object, the class object, and allows you to do that comparison. Again, pretty straightforward, and it is just a simple way of comparing. So the problem you have, when you start inheriting values and different classes from all over the place, and you're starting to do your amazing object structure, sometimes you forget, or you may be forgiven for forgetting, what an object is at a given time. So you can assert that object using the assert command to make sure that something happens, or you can just simply check, is this the object that I've now received, is it of this type? And if it is, let's do this with it. If it's not, let's do something else. Make sense? Pretty straightforward? Yep. And again, as I mentioned before, just to mention, the equals method often gives you very, very bad results in the sense that you do have to override the equals method when you utilize it. It's something that is pretty rough and ready. So if you're going to compare other attributes of classes, then you need to use the equals method, but you do need to define it and override it within your class. I hopefully will be able to show you examples as we go along with the class project. And that's pretty much covering that. So today we're going to be talking mainly about code quality. And as you know, that your code that you're doing for your project is worth quite some substantial marks, and part of your code will be marked in much the same way as your lab assessed work is marked. So there's, I run 50 tests on the server on your code, and we'll give you some feedback on that, or it should give you feedback on that directly. However, that's not the entire theme of your marking. So this time round, you're going to be marked on your code quality. And the code quality means how you've commented, how you've defined what it is that your code does. You've got to somehow describe it. You've got to assume that the marker doesn't know you're writing about a poker game, right? You've got to assume that there's no knowledge of that. And you're going to be writing this code assuming that whoever reads it is reading it new, okay? And another thing is the style, how the code looks. So if you were using Python, you would know that Python enforces you to sort of keep style-ish. The Zen of Python, I don't know if you've heard, if you haven't pulled them in Python, Python's method of coding enforces a certain style, a certain way of looking. Java doesn't do that. Java doesn't see white space. So realistically, you could code on a single line of code. You could just keep writing on one line. It doesn't care about the order of the code. It doesn't give you errors if the style is tabbed or spaced or anything of the sort. So that falls on your shoulders. So it's your job to make sure that when we look at your code and when the markers are marking your code, that it reaches a certain standard or a certain benchmark. Online, I think there is a code quality PDF that you should look at that will just review generically, not just Java, but generically what's expected in code quality. But we will go through a lot of stuff here today. So correctness is not enough. So just being correct. So when you supply your work and you've put countless hours in and you're really proud of it and it works really well, essentially that's the first step. That's the first step. You know, hands up who has written an essay here, ever? Who's written an essay? Okay, hands up who hasn't written an essay. Okay, so some of you don't know. So I'm going to guess, I'm going to just go on the assumption that all of you have written an essay. And if you've written an essay, what you've done generally, unless you're some kind of Einstein, is that you've written a rough draft, you've just thrown everything on the paper, what you wanted to talk about, and then you go through it and you go sentence by sentence by sentence and you turn it into a wonderful work of art that you then submit. Coding is the same thing, right? you will dump your brain into the machine code, and you will do all this kind of coding, and you'll get it working. That's just step one. So it's just supplying that working code, and you're like scared to move it because it's really brilliant and it's doing its thing. That is just the first stage. The next stage then is reviewing your code to make it both readable and cohesive. So it makes perfect sense when somebody comes along. So the biggest issue with coding is that the amount of time you spend coding your project or your work or anything that you work on is actually the small part of the job. The biggest part of the job then is reviewing that code later. Generally, you don't, these days anyway, you don't make code and forget it. I mean, if you harken back 30, 40 years ago, you'd have software packages that were written once and they were perfect and they kept running for years and years and years and years. Today, you'll go to the shops, you'll buy some software, you'll bring it home, and you've got a 60 gigabyte download for an update because they're not written in the same way. They're more complex. There's far more things that can go wrong and often do. Also, there are, you need to change work. Sometimes the clientele that you're submitting the work to changes, or the system that you're interfacing with has changed, or they've bought some new hardware. So you have to review your code and rewrite your code. Sometimes they say we want it all on the internet, which is a huge job. Or sometimes they say this part of the code isn't working fast enough. This is what we use this software for mostly. Is there any way you can improve upon that? So the point is you have to go back inside your code and then look at it again. And I can tell you, hand on heart, right? You can go back into your code and go, what? What was I thinking? And you can't, I mean, unless you've commented it really, really well, it can be quite hard to understand what your thought process was, especially when the challenge of what you're doing becomes, you know, a high level where it's kind of difficult for anyone to read. And that happens a lot as well, because you get these kind of brainstorms or brainwaves that you do something and you don't even know how you thought of it, and you're quite excited by what you've done. It does exactly what's expected and what it should do, and then when you look at it in a year's time, you're thinking, I don't even understand it, you know? So commenting is a huge thing. You will be reading your code more than you'll be writing it. And again, it's about maintainability, right? So often maintaining your code is a huge thing. If you've ever worked on Android, as an example, even Apple, iOS, the infrastructure keeps changing. So they keep changing the base of what you're working on. So, you know, they'll say, oh, well, this software only works for iOS 7 and above, or below, sorry. And then they say, well, you've got to update, you've got to update. And as they keep moving the train forward, they change the goalposts. So you have to keep maintaining your code. And again, if you haven't ordered it correctly, if you haven't made it look good, if you haven't made it read well, then you will find yourself spending a lot more time trying to assess what you had written than you should, because it should be quite intuitive. So what we're going to be discussing today isn't a hard and fast rule. You don't have to follow everything I say. And there are conditions, there are exceptions to everything I say today. You can do things in your own way if you feel that's the way you want to go. But everything that I'm going to be sharing with you today is generally what's expected within a professional environment. And again, it's not the only way, but it is a good foundation. And I would argue that you should argue with yourself if you want to change anything on the way that things are expected, then just have a good reason. And often there are good reasons, so you can. It's not like you have to do anything in a certain order. So quickly, what does this code do? Can somebody tell me? You can't, can you? Because you're not meant to. The example is designed to show you that it doesn't make any sense. I mean, you can read it, you can see what's kind of happening, but you couldn't tell me what the code does. You couldn't tell me its purpose. You couldn't tell me the reason for its existing. And that's the kind of issue. Now, partly you have issues with just there's commenting there. You can say, well, I've commented. You can see there's handle everything in the item. Handle everything, it means nothing. You've also got this issue of it capping. You see how the code is capping and it goes down to the next line? That makes it very, very difficult to read. Now, even if we had it not capping, it still looks really nasty. in the sense that you can't make sense of what's happening. The commenting isn't succinct, doesn't say what it really does. And there's no order or definition to what has been presented. So we need to write understandable programs. That's the key. So when I see your code for your project, I really do expect to understand it. Now, in the past, we've had quite a lot, or I've had quite a lot of students who just start with the variable A. So the first variable is always A, and then the next variable is B, and the next variable is C, and so on. And you just have the alphabet going down the code. And whilst Java says, who cares, you know, it just runs. Then when I come to Mark, it's kind of like, okay, that's not very useful. So the question is, how should we write our code? The first thing is commenting. You will be expected to comment everything you do. Commenting generally happens where you have, on the top of your code, you will be expected to do what's called a header. A header basically is giving your name and some information about you or the project, and generally then you go into describing what the project does overall, so the whole project, what it should do. Now, it isn't showing off, you put your name on some wonderful code. It is actually a way of just allocating who did the code and who should be told off, right, if it doesn't work well. But one thing you're not expected to do, and I'd ask you not to do, and you shouldn't be asked to do from what I understand, you shouldn't put your student ID on there. Your student ID is something that you should sort of partially protect. So as long as your name is on there, the system that we use automatically allocates the code to you. So we know who gave the code in. There's not, you don't really, technically you don't have to give your name. We know who the code was written by or who it was submitted by. But your name is expected just as part of your marking, right? So we would expect you to put your name on there as part of the header file. Now, whilst I'm on that, I'll finish this off actually. So the first class, the main class that you have, the main running class, will be where you put most of your work. So I'm of the belief that you should comment as much as you can at the top of the first class to describe exactly what the project intends to do. Then the next order is to have every other class at the top of every other class to again have a header, but also to describe what that class does. Not the overall plan, but just what that class does. And then as you filter down, you then comment every method needs to have a certain style of commenting, which I will give you a review of today. And part of this is to allow Java, which I don't know if it's taught often, but I know it hasn't been taught in other schools, but Java provides a really powerful tool for you to maintain and keep order of your code. And it's called the Java doc. Now, I know if I just go to the internet, the World Wide Web, if I just put in Java API, I've shown you this before, I'm certain of it. And you've seen this before, right? So I've kind of, given you a list. These are all the libraries that are available to you in Java that you can utilize. But what's pretty fanciful about this, so if I just click on anything, I don't know, just whatever this is, already connected exception, you can see that it gives some description of what that does, and so on and so forth. But what Java does is it allows you to create your own, and it does all the formatting and all the styling and makes a web page for you that you can utilize and use for yourself. Now, I've got a page coming up where I cover that, so I will I will cover that in a moment. But it's an incredible way, a really powerful way of ensuring that your code is both documented perfectly and available for other developers to use with clear documentation in the IDE. So NetBeans and other IDEs allow you to see what are called code tips, right? So the tips that, those little tips that come up to show you what you can use. When you press dot and a whole list of methods come up, you can define those yourself, and that's what we will be expecting as well of you in terms of the coding style that you have. And another thing is the naming convention. As I mentioned, I don't want to see A, B, C, D, E, F, G as your variables. You will lose marks for that. It's as simple as that. If you want to do it for fun, then it's easy marks that you just lost. That's the bottom line, easiest way of putting it. The problem you have is that you have to define your variables and your methods yourself, so you have to describe what they do. And you need to describe them in such a way that they're meaningful. You all remember camel case, so you have the small letter first on a method, followed by capital letters for every word within there. Use that, right? But be careful how big you go. So, you don't want to have a huge, massive sentence as part of your method. And the reason for that is because when I take your code and I provide it to the markers, what I do is I run some kind of Linux-based software, which is rather old, really, and it will basically cap it off at 80 columns, so 80 characters from the left or from the left to the right. It will cap it off and put the next lines underneath. So I would urge you to keep your lines less than 80. In fact, aim for 79 characters across. And what you can do, if you remember with Java, is you can, depending on what code you're looking at, I don't know what code to show you, but you can basically pop down, these can go on separate lines like this if they extend. Now what you can see, is there is a line here that kind of defines the end in general anyway. This is a basic line that tells you, look, don't go further than that. It's a guide. It's a guide. And what I'm giving you is a guide. It's not that you have to do it or hell will break loose. No. This is just a norm and an expectation. And your code will look worse to the marker if you don't abide by the 80-column rule. And you don't want to be marked on code quality being, what's the word? You have a handicap in the sense that your code won't look the same as you provided from your work. On your screen it will look one way. On our paper it will look completely different, and you'll lose marks for that. And another thing to be aware of, another thing to be aware of is spacing between pockets of data. So if you have a method that does something, then obviously group it together in a method. If you have a huge list of code and certain pockets of that code do certain things, it's always a nice idea to put a space or an extra line between that code so that it actually looks neater and more readable and more presentable on the screen. Going on the commenting, one of the things that is quite tough is choosing a meaningful variable name. You've seen this meme before. It's a big thing. I mean, often when you haven't programmed and when you're learning to program, it's just something you do, right? You just name something trivial, and later you go back and think that's not the right word. So this is often sort of a difficult thing when you work for a professional company. So when you're trying to work for a professional company and they really they have high expectations of code, of coding style, this could be you stressing that you can't think of a good variable name. And this one, setting up fancy variable names for fun. You'll rename them later. I have a friend who I went to university with, and he used to do this. And then the deadline for an assignment came up, and obviously he tested his code, and he was rushing to get to the end. And he submitted his code, and all his variables were funny words like poop and banana and and such things. And as much as it became a joke in the class the next week, of course, with the lecturer, with the professor. But yeah, he was quite embarrassed actually. So yeah, don't try and read in. You have to think of them beforehand. And again, don't overextend the variable name. So when you've got a huge variable name, it's really hard to read. It's really hard to understand. It's much like a hashtag, isn't it, in Twitter or something? You have like, hashtag I'm eating my soup for breakfast because I'm here having a great time on my own. That type of thing. It's like this long and you think, oh, yeah, silly. So avoid those as well. And the issue, once you get good at programming, this is pretty much how it becomes, right? Naming variables is probably the most difficult thing, because you want your work to be readable, you want it to be concise, you want it to be understandable. On saying that, there is another school of thought that if you're producing software for yourself and you're copywriting that software, and you're then putting it out to the world for them to purchase, and you're looking to make $1 billion because you're really happy with what you've done, there's another school of thought where they put it through a software kind of grinder, which randomizes your code and all the variables, so they're completely unreadable to anyone. And the idea of that is that if you can't reverse engineer, it's harder to reverse engineer your code in such a case. So, again, the main program, begin with documentation. So that's your first, you always have a main class, a class with the main method. You can have more than one main method in different classes. So each class can have a main method if you wish. But generally you'll have one class that is your main method, and it's that class that you'll want to give the bulk of your documentation. And in that, you kind of give a broad brush overview. So you're kind of defining what the code should do, not what it does, what it should do. And that way, that if you've done, how can I explain? So often I've worked on projects written by other people, and often I'll look at the project, and I've been online, and one thing you'll see on forums, you'll see this all the time, is that, it's hard, I don't want to disparage, but some self-taught programmers who are very clever, nobody's saying they're not clever, often say that if you can't read the code, then you're not a coder. You don't need commenting, you just read the code, and the code tells you what it does. And there's some truth to that. The code does tell you what it does. But the non-truth, or the problem with that from a professional context, is that I might write some code and say, yes, eureka, it's doing exactly what I want it to do, and I'm so proud of it, and I'm just going to go and show my mum because I'm so proud. And I show this code to my mum, who doesn't understand anything about computing, so doesn't really care. But the point I'm making is, you're really proud of your work. You think it's doing everything you should do. And I've worked on projects where people have done this great code, no commenting, and I've read through it, and then I've gone to someone else and said, is this really trying to do A, B, and C? And they were like, yeah, that's what it's doing. But I understood the code to be wanting to do, D, E, and F. So what I'm trying to say is that just because you think you've got the solution, if you're not describing the problem and the solution in actual words, sometimes you can make a mistake. And just because you think it's right, the code might be wrong. It might function, but it's not giving the right values. So what you do is you describe the contents of the method, or the function of that method, what it should be doing, and then you do the coding for what it should be doing, and what you expect is that they match. What can happen is that they don't match. There's a mismatch, so that the code doesn't actually do what you think it does, usually logical errors or some kind of truth tabling errors that can happen. But by writing it down, somebody can read what it should do, look at the code with fresh eyes, and go, no, that's not what it does, because of this decimal point, or this comma, or this something else. So there's a huge importance there to describe exactly what each method does, which I'll show you with the next slide with the Java doc, on why that's also important for future developers as well. So every file should begin with documentation broadly. The main project should give a lot of documentation. Every non-trivial method should begin with a documentation. I would argue that almost every method, every method that's public must have documentation, because you're making it public and you need to describe what parameters are required, what values, what they do, etc., etc. And you don't have to document obvious code. So when you increment a counter, count plus plus, you don't have to do / increment a counter, right? Because you kind of know that. So generally, only explain interesting subtleties, little things. Don't explain things that are obvious. But again, we'll come to that. Now, looking at the time, we're probably a good time to have a break before we go into the Java doc, which I'll showcase how that works. So let's have a 5-minute break, and we'll continue from there. There you go. Wake everyone up. Hey, how are you?
I'm trying to see.
Okay, so this flat is not defined within this context, so you still would have to put heel type dot flat. Do you know what I mean? Because it doesn't exist within this locality.
So, are there any possibility if I want the user to decide what the word should be? Like, if I want the user.
No, that's not working either. Estimate heel type value of. Oh, should it? Can I just? Is it expecting? To control space. Is it value of you're looking for?
I actually just try to see, try to find what to do, but it was just some kind of testing thing. I tried to see how the enum type would work.
Oh my gosh! Can't touch your keyboard. I was going to type in ordinal. Press Control Space. So the ordinal. Oh. Actually, I'm not sure. What are you attempting to do?
I have no idea. I was just
Oh.
trying to test.
Oh, okay.
And I want to see if I want a user to tap in, what kind of that enum would be like.
You have to define the enum, so that's kind of like a definition. So you.
Is that like this or?
Yeah, that's defined, right? So this is almost like a fixed final value. So it's a it kind of it's what's the word? It's immutable. You can't change these values. You can't add. It's not an array. You can't add to in runtime. You can't add to the enum.
If like I have defined this view type and I want the writer to choose what kind of tab, what kind of view tab it is, like I create an object like a shoe one, and I want the user to choose what kind of view tab it has.
I see. So what you probably want to do is have something like a switch statement, and put each value, and depending on what the user's requirements are. It responds. Is that what you mean?
Yes. And if I want to like type in here, like I want to choose what it's like, do I have to use that view type dot something, or can I just type in flat? No, I can't do that.
No, because it's a separate class. You have to call the class and the actual. I'm going to call it the variable. And you have to call the class because it's in a separate class. Does that make sense?
Like if I have a shoe S1 and at the first time I don't know what kind of dress shoe it is. I just have these 3 variables, and then I want to add a hue type to it. So what could I do other than give it this dot or something? I can't
so you can iterate through. You can choose the index of each heel type. Is that what you mean?
So I can do it by.
Because essentially they're constants, aren't they? So an enum is a list of constant values, and you can call each value by its index value as well.
So it's like
So you can call
give it a column 1, 2, 3.
0, 1, 2. Yeah.
Like this, and
Yeah.
I can use index of to call it.
Yes, and you can call the values of. So you can call the values of that value and give it an index, and it will call the value of. Is that what you mean? Probably not. Send me an email with the details on there, and I'll give you more. I might understand more what you're trying to ask. And
Right.
yeah.
And the minor problem is for the assessments 4. And after submitting it, it won't give the mark. It just gives like a brief
Right.
testing. It just gives me several, like 4 testing results. Something passed, and we don't know the result of it. We don't know our
Oh, okay.
grade of it, how much
Okay.
marks.
I see what you're saying. I've asked Nye to look into that. Was it you that emailed me?
No.
Oh, okay, I had an email about this. I'm not sure because when I do the testing and I do a preliminary this word test. I do an initial test. It gives me everything I need, so maybe I'll double check that. I'll need to fix that fast if it's an error. So we're aware of something like that. I think someone else has mentioned that.
But I didn't receive the grade
When was the last time you submitted?
last night.
Oh, okay, so recent. Yeah, okay. I will find out. I'll find out why it's not doing that. It could be something trivial, or it could be. I'm not sure. But it was working for me. That's the point. So I have to get students to test it because it gives them more. Yeah. Okay. Thank you.
Just on the assignment quickly. So with the simple part, I've done that, submitted it, that's all fine.
All of them.
And with the next bit, I can see that a lot of tests are for the next bit, and I'm thinking that I want to do it, but I'm thinking of doing it and then not submitting it because it's just I don't want to
Jeopardize your marks. Yeah.
because I could make a silly mistake or something on comment something badly because it is harder
Yeah,
to do.
yeah.
But you said I can still get full marks by
That's
not
right.
submitting.
That's
So
right. Yeah, I think
I
that's
still want to do it.
that's a valid position to take actually, and you're right. If you feel that way, I would err on the side of caution and do exactly what you just said and submit the easy
Because I
one.
can still learn stuff from doing it.
Yeah, exactly. It's there to learn.
Just
But
checking that I'm not gonna lose marks, I guess.
no, you won't. There's not at all. Not even a bit. It's just there to sort of challenge a little bit more. Hopefully, give a little bit more
It's
complexity.
definitely harder, that's for sure.
Yeah.
And the other thing was that with the Enum class you recommended making, if we, I have a way that doesn't use that. Do we have to?
No, you don't. Actually, when I mark your work,
Yeah.
I literally run the poker.java file, compile it, it runs through a series of tests, and then we then look at your full submission, which gets sort of put into a PDF form and sent out to the markers with a schema, and they just review your quality of code, really, because if you've got your marks and if it's successful in terms of its production, it doesn't matter what you've used. But just bear in mind, which hopefully we'll go through now, be careful on code repetition, be careful on that kind of stuff, the structure, be careful on commenting. That's what we're going to be marking manually on. So, easy marks to keep, really.
Yeah, of course. Yeah.
But at the same time, you're right, don't worry about the tough one. Unless it's perfect, unless it's perfect, then I would do the same thing.
Cheers.
Yeah, no worries. Thanks.
Very quick.
That's all right.
See, I was just sort of playing around with it. You can't have. This is my derived class. Sorry.
Yes, okay.
is-
Extends.
So I was wondering, you can't have this and a super in the same constructor, because you said
Does it work?
no, because when I did this, it will be like
Yeah, because this is going to call another constructor within this object.
First statement in constructor body.
Yeah, so if you so you still need to, this actually calls another constructor within this context, but that has to call super. Do you know what I mean? So super has to be called if the super's got a constructor. If the super doesn't have a constructor, like a defined constructor, then you don't have to. It'll do it itself.
Oh, okay.
Right? But yeah, just play around. I mean, the easiest way to learn, or the best way to learn, is just to break it. Keep breaking it and trying to... Yeah, no worries. You're welcome. Okay, guys. So let's look at java8. Now, java8, as I mentioned earlier, is quite powerful. I'll show you how it works in both the NetBeans and on the command prompt so that you understand what's going on. So what I'll try doing, I'll try showing you first and foremost. I'll try showing you first and foremost some really basic code. Oh, actually, I'll tell you what. Let's do it this way. Okay, so I've got a Java8 example. What I'll do is I'll actually make a new example to show how it works. So let's just make a new Java8 example. Oops. And the first thing I want to demonstrate is how Java8 works. So if you do, you make methods, you make a class, and you fill that class with code, and in that code it's got methods, and those methods do whatever they do, right? So if we do a main method here, and then we just do, what I'll do, I will create default values called var1, very, very thought out, very carefully thought out variable names here, so please don't copy me. Right, so what I've got is this, and I'm going to quickly just generate getters and setters. So what I'm doing is auto-completing the code. So I have these variables, which are forming part of the object, right? And I've got a main method in here just for fun, just for giggles. And I've created getters and setters for each of those values, right? I do have to do something. I mentioned this before. For some reason, NetBeans just stops me typing unless I do that. Okay, so what is a Java8? Well, what it is, you know that the double slash like this is indicative of commenting, right? So this is just a comment. We know that, right? And I'm not sure if we've already gone through, I think we have, but if you do a slash and a star, it gives a multi-line comment. So you can just type in here multi-line, right? And that is pretty straightforward. So those are the two sort of easy ways of producing commenting to your Java code, as you would expect, and I'm sure you've already used them. So, but Java8 is slightly different in the sense that just before any method, you do a slash and a double star, like so, and then in NetBeans, when you press enter, it simply adds the parameter or the return types, any parameters and return types, and it produces these stars or asterisks in between. And here you will type in something. Here we type something to do with the method, right? Right, so that's pretty straightforward, isn't it? Right? And the return would be variable or one that changes the world. Okay? And big deal. That's just, it is what it is. It's like I've just put some comments at the top. But what that's actually done is that's produced, not quite yet, but it will produce an entire web page that looks exactly like the API, and these values will be available for me to use to do with what I want to do. So actually, let me get rid of the main here and show you what I mean by that. Let's put in a constructor. So insert code, and we're going to say constructor, and we'll just put in these values. Oh, actually, let's leave it empty just to make it easier. So we've got a constructor that does nothing except for sorry, I have to keep closing it down, opening it up anytime I use autocomplete. Just a glitch, I guess, that's been ongoing. And here I'll just print out starting. Starting. Okay. So we've now got a small little code called new Java8 example. I'm going to create another class in that same project, just call my Java8 main. And here I'm just going to say public static void main, and we're simply going to say, what was it called? New Java doc, new Java doc JD equals, there you go. So I've created, essentially what I'm doing is I'm just simply creating a new object called new Java doc, right? So, but what I want to show you, in fact, I'll just do a couple more of these. Let's just do one here as well. Right. What I want to show you is when I run this, or when I type in JD now and press dot, and you can see my variables here that I've just had. When I go to them, here we type something to do with the method, right? So if you look, do we have? Oh, which one did I do? This is so cool, huh? So that information that was attributed to on top of the method is now available to describe the method. So when you're typing and coding, and you have a really complicated method, but you maybe you have two methods that are very similar, but they do very different things, and you don't know which one to use. Well, now you can just hover above them and see what they do, because you can get that information as you're coding. And this makes it really, really, really quick to code your own methods and stuff, and so you know what they're doing. But the concept is that you do have to provide this type of commenting above each method. So that's the first thing. The next thing I want to show you, and I'll just call up, hang on, oops. Let me just call up my Java folder. Oh, come on. All right, so what I have here is simply a Java folder with Hello Java written in there. And that code there, if I just show you, I'll hold this up here. So I want to show you something pretty cool that some of you may already have used, but for those that haven't, you'll see what kind of is happening. So what I've got is this hello class is this, right? So I've generated this, and this shows all manner of interesting information about your code to the developer using it. I've just written some junk there that kind of gives some information back to the IDE, right? And then the next thing to do, hang on, let me just call upon this. So this is now a standard terminal. It's a little bit, I'll do it like this. So I'm going to go into my Java folder. I'm going to show you what's, oh my gosh, I need to put my keyboard lights on. So I'm going to show you what's in there. You can see that it's the same as what we have here. You can see that? So this is what's inside that folder. I'm in the same folder. It's the same one. But what I'm going to do, I'm going to type in Java. Do you remember you can do Java compile, or you can do Java to run your file. Do you remember how we did that? You can type in Java doc, and then the name of the file that you wish to Java dockize. I made that up. Don't use it. It's not very funny. So we're going to Java doc this, like that. And I want you to pay attention to this folder, and obviously down here as well. I'll move it slightly higher up so we can see what's going on. Press enter. And now it's generating. Look, it's generated a pile of code. See that? So what was there originally was just 3 files. And now there's a whole heap of files in there, including JavaScript and style sheets and all sorts. So it's generated all this thing. And then if you go to the name of the Java class that you are looking at, so in this case it was hello, if you remember, and I open that, you can see now there's an entire Java doc completely edited and designed to look exactly like any other Java doc that you can utilize in your coding structure. So you can see that, if I just pull this like this, so this get doc example, here get doc example, shows everything about it, so what it's requiring, the information that you've given it, the text, as you can see there, that the values that it's going takes in a string and does absolutely nothing, takes in a number again, does absolutely nothing, because it's just an example for you. The string Bob, for no reason at all, is returned, right? So that is an incredible incredibly powerful way for you to develop documentation for your code, as easy as just typing in javadoc. If I recall, on NetBeans, I think you simply have a build javadoc somewhere. There you go, generate javadoc, which does exactly the same thing. So that just generates the javadoc, yeah, whatever that means, and does the same thing on your entire project. And then it gives you this incredibly useful, very rich environment to review the code that you have in such a way that it just makes programming a breeze. So this is something to really consider when you're coding. And in NetBeans as well, you have these, I don't know if you can see, I'll try zooming in on here. You've got these little squares here. So yes, you may have a situation where you have lots of, let me just copy this to show you what I mean. So I'm just going to mess it up a little bit. You might have tons and tons and tons and tons and tons of terrible commenting like this. But of course, if you simply click on this little square here, it just hides it away. So you can still code without seeing all the commenting and stuff. And just, you can hover, I think, there you go, you can hover over it. It shows you what the commenting is anyway. So these are just really small tips to enable you to develop faster and more productively and maintain a really good quality, a very strong quality of documentation. And in many ways, it enforces you. If you follow this principle of creating Java docs, it enforces you to create meaningful documentation, unless you copy the silliness that I've used in the examples, of course, which I advise you didn't. But it enables you to actually define so many different access points to learning what your code does. And as your code gets bigger, and you'll see this with the project, the main project that you have, it does get harder to manage, and you do need to have these little tooltips, these little things to kind of help you to develop as you're going along. And the bigger the project gets, and they do get enormous, the more you work in code, the bigger the projects do get, to the point where no human would be expected to remember what's going on. So you really do need to fall strongly onto these principles to help you. Any questions on Java docking? Made that word up as well. Yes?
Is it pretty good as well for getter functions and getting functions into string functions and things like that?
Yeah. Java doc, anything and everything you wish. Again, if all you're doing is getting the length of something, and literally the get length gives you the length, maybe, do you need to document it? I don't know. Does the name of the method give enough information? That's for you to decide. But, I would advocate just Javadoc everything. Just Javadoc the heck out of all your code. And then you get this great resource, this web page, an entire web page with links and everything that lets you navigate through your code from a web-based environment. You can pass that Javadoc on to other people and ask them to look at it, to edit it, to give you feedback without giving your code. I mean, it literally just gives the kind of meaning to your code, So it's a really powerful tool. Yeah, thank you. Anyone else? It's very hard to see. Oh, I can see now. Wow, it's a few of you. There we are. Okay. So, again, you implement before any method or class, Javadoc. So you use this prefix /, close it with //. It's generated by the JVM, so it's completely auto-generated. You don't have to do any work. It makes it really easy. It's built into NetBeans and other IDEs, I'm sure. And you can do it on the command prompt as well. And it just floods your files with the structure that you need. And it creates the API for you. So you can add to your own API, have your own manual for your own code, which is wonderful. So the key for your project will be tidiness as well. So you're going to make your code look neat, consistent layout. As I mentioned, 80 columns is standard. Also beware of tabs. Now, let me show you something on tabs. If you go into NetBeans and you go to Preferences, let's open it on this page. And I'm not sure where I'm going to find this, but I think it's, no, that's not it. So it's the editor, commenting, formatting. There you are. Yes. Okay, so you can see this here where it says expand tabs to spaces. It's automatically set up on mine. It probably is the same on yours. But that's something that's very useful to be aware of. Now, if you're using something like J-Edit or in IntelliJ something, whatever, there's tons and tons of IDEs that you can use, and some of you have showed me different ones that I've never used before. You've got Eclipse and everything else. What you have to be aware of, and this is quite important, especially when you're submitting your work, and I can honestly say that I've had lots of students lose marks on what I'm about to tell you, and that is that when you're coding, it's quite natural to hit tab to get the tabulation right, especially in an IDE. But not all IDEs treat the tab in the same way. NetBeans can be defined, as I just showed you, so that a tab is equal to 8 spaces. Between 4 and 8 spaces is normal. I would advocate that if you're not using NetBeans, then never use the tab unless you're sure it's producing spaces. What you don't want to have is some lines with tabs that look exactly perfect and others with 8 spaces or 4 spaces, or whatever you've decided tab is. And then later, when I see your work, I've got 4 spaces, 16 spaces, 4 spaces, 4 spaces, 16 spaces, because the tab system works in a different way. There's no norm for how an application utilizes tabs, right? You may yourself gone into Microsoft Word, and you can move the little tab triangles at the top to define your tab. And it's much the same way in any other IDE. What you need to do is to get used to either just use NetBeans. That's the first thing. But if you're not using NetBeans, just get used to putting spaces in to make sure that everything that you present to me for marking is uniform. Okay, so the tidiness, the way your code looks, is really, really important because it's easy marks. These are almost free marks. You don't even have to provide complicated work. It's just keeping it tidy. And what that means is that all your lines are perfectly. Let me show you. All your lines are perfectly lined up. Let me get rid of this. Oop. So you can. This. Have I got anything that's reasonably, we'll come to that later. Okay, so what I don't want to see is things like this, right? And I promise you, if you mix up tabs and spaces, that's how it might look for me. And I've had it so many times. And then I've had students coming to me with their laptops and saying, look, it's really clean on mine, it's the same version. And I'm saying, but look, it's not clean on mine, it's the same version. And that's simply because they've used tabs instead of using just spaces. So every time you're putting in your spaces, just use spaces. Again, if you're using NetBeans, it does it for you, but just double check that it is. Commenting. When you're putting in inline commenting, the commenting that's in line with your code, so we're not talking about java8, we're talking about commenting that's in line, then consider how it looks aesthetically. So when you're looking at that code, does it look tidy? Does it look in line? Sometimes if you've got lots of commenting all the way down because you're doing something really interesting and it needs to be explained, sometimes it's better to line up all the commenting so they're in a straight order, and that sometimes looks really, really pleasing to the eye. So look at your code and decide whether you think it looks presentable and tidy. Again, as I mentioned before, use separate lines to blank off different sections of code. So if you've got code talking about lollipops and then code talking about car wheels, and they're both on the same sort of structure, separate them. So there's a gap between them so that you know what each one is doing separately. And again, use commenting to explain each section. Avoid copy and paste coding. This works in 2 ways. If you copy stuff off the internet and paste it into your code, your IDE will fix any issues like these things here being 66 and 99, right? It makes them into 2 little lines. That's not what I'm talking about in terms of copy and paste. What I'm talking about in terms of copy and paste is when you have the same code repeated again and again and again and again in your code, because it's doing the same thing to different parts of your project. But that's something you need to avoid, and that's something you will lose marks for. So if you've got repeated code that's just doing exactly the same thing, because it's needed, but you haven't developed the technique to make it reusable, then you will lose marks for that. And again, these are easy marks to make sure that you have. And just to qualify, everything I'm talking about now is after your code works, right? So your code works at this point. You know what I mean? So this is all stuff that you're looking into after you've finished your project, much like the essay example. You write an essay once, and then you go through it and you make it look nice, and you make it sound nice, and you make it presentable. Same with your code. So this is after you've got your code working, so don't worry about it whilst you're trying to get it working. Another issue is if you find an error in your copy and paste, if you copied your code down throughout your code and done different things, and you find an error, often the error is repeated. It's really hard to find those errors in all the places that you've copied the code as well. So, refactoring isn't something that always works. So that's something to be avoided. So don't try to limit the amount of code that does the same thing to one area. So what we have next, hang on, we've got this code here. How could we rewrite this code to simplify the style? What could we do? Look at this code. It's pretty basic. So you have if A, then if B, then do X, then do Y, else if B, do X. Oops. Right, so extract X out and have a look at A and B, and then just do Y. Is that what you said? So what is happening? There's a very good, so I'm just tying my shoelace on one leg like a flamingo. Okay, fall over. Yes. Yes, so it's basically doing the same thing. So you got the actions is to do X and Y, or just X, or just Y, or just X, or do nothing, right? So this code can be simplified like this. If B, do X. If A, do Y. It's the same thing. But you can see how simple it looks, how tidy it looks, how easy it is to read, and how the logic just makes sense. So often you will write code like this just because it's how you're thinking, right? It doesn't mean it's wrong. It does work. The code will give you the results that you're looking for. That's fine. But the issue you have is that when somebody reads it, they don't understand what you were trying to think, and it makes it hard to read. Whereas this code here, it's so straightforward. Does that make sense? All good? So the key of thumb is, I don't know if you've heard the phrase, keep it simple and stupid, or keep it simple, stupid. And the idea is that try and do a very simple solution for everything that you do. It's all too easy to get blinded by complexity. And there is an actual term, which is called code blindness. And code blindness means that you've been looking at code, usually looking for errors, for hours, if not days, and you cannot see why something isn't doing what you expect it to do. And then you'll say to your colleague, your friend, your pal, your coding partner, whoever, can you look at this code and tell me what's wrong? And they'll walk up to it and go, oh yeah, you've got a string there. And then it'll hit you and you'll be like, oh my gosh, I spent 2 days looking at that. you become code blind. It's called code blindness, and it happens so much, especially when you're in the depth of your field, doing some complicated bit of work, and you've been doing it for too long. You can't see the wood for the trees is the term often used. So you need to keep it simple. I'll run through an example in a minute of an actual student's work a few years back that was submitted, a real student's work, and how we can simplify this actual student's work. So if you do a really bad job, your work might be on one of the next lectures. So that might be something to look forward to. I don't know. I'm kidding, of course, but this is the case. There's also the dry principle, don't repeat yourself. So define each piece of logic once. So if you've got something logical happening, do it once, put it in a method, and call upon that method as often as needs be to keep the code readable. And one of the things that we'll see in a minute is that less code means fewer chances to make mistakes. And that is the key, right? The easier it is to read, the easier it is for you to be able to decide if it's doing exactly what you need it to do, and if there are any semantic errors. Yeah, so semantic error is an error that doesn't cause a problem, but doesn't give the right results. And those are very common. Keep your definition short. Methods shouldn't be more than a page. Shorter is better. I discovered when I started doing OpenGL, which is like a graphical language for the graphics card, there's a rendition called Joggle, Java OpenGL. And one of the things I would do is I would make a big, huge graphical monster or something that I needed to use in my display. I would grab all the parameters, all those points that made that, and put it into a method so that it would be quicker. And Java would go, no, I can't do it. It's too big. So Java has a limitation per method as well. So you have to then alter the JVM, the Java virtual machine, to accept such things, which is a bit of a headache for most. But the point I'm making is to keep your methods short. Java does have a limit on how big they can be anyway. They're pretty big. When I say a limit, we're talking massive, right? But generally keep them short just for readability. And sometimes split a method into multiple methods depending on the nature of what you're doing. And that is often a very useful way of keeping order and control over your code. So in IDEs like NetBeans, you have a tool called refactoring. I don't know if you've probably heard of this. It's basically renaming. So if I wanted to change this class example here, oh, hang on, get it right. There you go. I can give it a new name, and it will change. It'll change that name everywhere. That's probably not a great example. So here we have like the student ID or something. If you change the name or refactor the name, what the IDE does is it looks for every connection to that name and changes that name as well, including those references within the Java doc and the documentation. So it goes through your entire code and changes. So in essence, what I'm saying is, if you've named something A, B, C, D, E, F, G in your first draft, right? Your first draft is the one you're not going to submit to me, are you? Then you can go back, and you should go back, and alter all the variable names and all the method names to be something meaningful using refactorization. And essentially, I'm trying to find something that's got useful refactoring. So this D here, so if I refactor D there, and I just type it day of the week and call it day, you can see all, you can see all the versions of day are also changing. So you can see it all changes everywhere where that is placed. It changes it at the same time. So I'll just put it back to D. Yeah, that's refactoring. Use it to make sure that before you submit. So every one of you have refactoring in mind before you submit your work to make sure that your variables and your methods are named as they should be. So what I'm going to just show an example now. This is actually this was a submitted piece of code, or a portion of some submitted piece of code from an actual student that did something, and it's an example of what not to do. So what you can see here, can you tell me what's wrong? What can you see is wrong with this code? Oh, just to give you a context. So the code is talking about a classical board game called checkers. I used to play checkers as a kid. I can't really remember the rules that well today. But checkers is like you have these, or sometimes it's called drafts. So you have these little round sort of coin-shaped things on a chessboard style board. And you have red and black colours, and you can move one way, usually, unless you're a king. And you can jump two if you're taking a player or something, or you can move once if you're not. So there are these conditions on the movement. So this is looking at a checkered board, which is of size 8 by 8. And you have two players, top and bottom. One player goes up, the other player comes down, or forward and backwards, depending on which way the board is, of course. And what this is doing is this code is ensuring that certain conditions are met. It's checking to see whether the piece is on the board. It's checking to see whether the piece is moving a certain amount of positions that are valid. And it's checking to see whether the piece isn't falling off the board, so it isn't leaving the board after its move, right? So with that in mind, can anyone see anything glaringly obvious that's problematic with this code? Keep in mind what we've already discussed. So with the code quality, the style, the repetitiveness, that type of thing. Can anyone see anything that stands out to them? That's a fair point. There's no commenting, yes. Commenting aside, it's a very good point. Well observed. Commenting aside, see? Yes, a lot of codes are repeating, right? Can you all see that, for example, we're constantly using row plus row, 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 right? As one example. So how would we fix that? Well, we could create a local variable called int new row and put row plus rows and then put new row where each row plus row is. And I think the contents or the context here of what we're trying to do is make the code readable. Because let's go back one, you know, you can read that, of course you can read that. You know, we're smart enough to read it, but it's not easy to read, right? It's really sort of a bit blur. Like, okay, king plus column, king plus col plus columns less than equal to 8 plus col plus columns greater than equal to 1 plus rows less than equal to, it's very, you can see it's very sort of cumbersome to read. Would you agree? No? So int new row would be the first thing. And then of course you can then see that the same thing is happening with columns. So col plus columns is also taking place. So we could easily make a variable for that, new columns. And you can see already that the code is looking a little bit shorter, right? A little easier to read. So now you've got king plus new columns plus new column. You know, you can see that that's becoming easier. Something else that we might look at is that this condition is taking place on each if statement. So there's an if statement here, there's an else if statement here, there's an else if statement here. And in each one of those, this same sentence or this same code is being implemented. And again, nobody's saying it's wrong. We're just saying that it's repeating itself. What can we do to repair that? What would you recommend? Anyone? No?
We have a nested if statement.
A nested if statement saying...
we combine the terminal part with the part of the three if statement together.
Right, I'm not sure quite what that means, but I think you're onto the right track. So because each if statements are doing the same thing, we can move that one statement to the top, see? Because all we're doing, see, we don't need that there. We can just say, well, that's a condition that's always met for each one of the if statements, so let's just do it once. Do you see how that worked? All three, now it's once. You can see how it's simplifying? So this was an actual piece of code from an actual student. So just keep that in mind. This isn't just make-believe. This is the type of thing that can happen. What else can we see? Well, you have row less than or equal to 6, which can be row, now it can be row, oh sorry, we can change that to new row less than or equal to 8. It's to do with the rules of the game and keeping it on the board. Then the next thing that was picked up by just doing this refactorization and making it tidy was that this condition here actually is considered an error because it's checking to see if it's black, if the rows are equal to -1 and the rows are greater than 2, which would make this off the board. So that should have been rows greater than or equal to 3. It's only by refactoring that you can see these things easier. They stand out more as you're looking to sort of review how it looks. Okay, so that was an actual error that was discovered only through doing this, and otherwise it was not spotted. So that bug, yeah, row should have been, so as it says here, row is greater than 2 is a bug and should be row greater than or equal to 3. Then we can make this row in itself new row greater than 1. Again, the rules of checkers escape me because I haven't played it since I was a little boy, like a few years back, not too long. Anyway, so we keep moving on, and we keep looking at the same things and changing these to make each thing smaller. So we move all these things up here to be on the same row because you're doing the same sort of thing. And then the next thing we can see is that each one of these things now, the if king, if else is red and rows is equal to 2, if else is not red and rows equals to, well, the first thing would stand out to me, but I think we'll come to that in a minute, is that. But you've got these things that's doing exactly the same thing on each condition, so we don't want to have that. So those things can be one thing, right? So it's that or, so you're changing the else if to ors, right? So now you're having if it's king, if it's red and rows is equal to 2, and if it's black and rows is equal to -2, then just do it once. Again, you can see that the code reuse is just making it smaller, right? Then the if here can actually then change because it's an if inside an if, which is the same as saying and. So that if can become an and. And then you have this thing here, this red equals false. Well, that means not red, right? So rather than saying red equals false, you say not red, which makes the code distinctly smaller. So the value for rows then depend only on red, so you can change that to be this ternary, yeah, that word, this other if statement. So if you remember that's an if statement there. So red is 2, and if it's false, if red's not true, then rows becomes 2 if red is true, and false, or -2 if red is false, right? So that's the first thing there. Again, it's making it smaller again. And then, is there anything else we can do? Tidy it up, put it together, so now it looks like that. Are we happy with that? Everyone happy? Not really. So we can then look at this value here appearing throughout the class, and you can change it to, because what this is actually doing is saying, hey look, this is checking to see whether the piece, the little chip that you play the game is on the board, right? So if it's on the board. And a concept that I want you to get into your minds is when you're developing your code, is having methods that name the function that they do. So what we can do here is have an onboard method that does the same thing and then call onboard. And the reason you do that is because it's readable. now the code is reading a little bit better. It's checking if the new column and the new row are on the board, which makes sense, right? So that makes it tidier. Again, just to make it clear, we're not trying to condense the code to make it small. We're trying to condense the code to make it more readable. Okay? So there's a distinction. And then you've got the same thing going on here. What do we do? Rows, the magnitude. This is looking at the magnitude of the rows, and it's looking at it twice. So we can change that to be red is, because at the moment it's looking at the condition of being 2 or -2. So we can make it a bit tidier by saying red is equal to this condition of rows is greater than 0. So red will become positive or negative, or the Boolean based on that. And then capture. The code to move is almost the same as capture. So we can make a capture and a move function in C method, and that will allow us to read it a little bit more succinctly. Now, because we're using move here, we're using the key shift. Again, this is not a perfect rendition, but this is certainly making it far more readable in terms of the actual submission that was given. And then that pretty much covers the final tidied results. You can go as far as you like. You can develop these things in your own unique way that enables me to see that you're producing code that's totally readable, very clean, very concise. And I really need to drum it home that your project, which is a sizable mark, will depend on easy marks, that you keep your code concise, that you keep your code commented, and you keep it tidy. Yeah, those are things that you've not had to use, not had to care about before in terms of your submissions. We've only cared about the correctness of the output. But this case, we'll be looking at the correctness of the output and the style of your code. Does that make sense? Everyone happy with that? Yeah. So here's it's not easy for you to see that, is it? So this is the side-by-side comparison, which is just there for you to review, really. You can see that one doesn't read as tidy as the other one. They're both, generally messy, and I think, you could go further with them, in all honesty. But it certainly makes it a better way of providing the code. Now, I had planned to actually start a toy car project with you as a way of describing how to develop all the things that we've learned into a code. What I'm going to propose I do, and I'll put it to you in a vote this week, is maybe I should do an online video describing how to do certain things on that. I think that's what I'll do. So, just to recap, why is the code better than the original? Reorganizing, the first thing, the reorganizing found a bug. The methods were shorter and easier to read. The logic was still a little bit complex, but self-evident. Handles twice as much of the problem in the same number of lines. Makes it clear how to move and capture. And essentially, it just sort of tidied up everything. And then you can use the onboard class, that same capture, keeping the board thing again and again and again in your code. I do this a lot, guys. I tend, guys and girls. When I say guys, I mean guys and girls, by the way. I tend to write my own utility methods all the time to help me code. So one of the biggest ones that disappears is system.out.println. That immediately becomes print. So I make a print method just to make my code easier to read. And I do different things like that all the time, and I'd advocate that you do the same. So in summary, what I want you to do is to document what your program does. Listen strongly to the words that I'm using here that you really do need to document. Don't make it a 2-minute before you submit thing. Give it a good portion of time to document your code concisely. Don't overdo it, okay? I don't want to see, if any of you have programmed in Android and you look at the Android API, you'll have 20 pages of comment for one command. I don't want to see that. I just want to see concise commenting describing what your methods does, what your classes do, the different classes that you use. Remember to keep a header on each class. Don't use your student ID. Think of it like an essay. You write the first draft, and then you start tidying up and expressing yourself more clearly, making the code more beautiful. Use the refactor. Any IDE has a refactor, so you can rename anything. Make sure it's called refactoring, because if it's just renaming, you might just rename that one variable, and it might just break your code, right? So make sure that you're refactoring the code. Organize your documentation. I would say use JavaDoc, not explicitly for this assignment, for this project. It's not. We're not going to be testing your. I don't want you to submit JavaDoc files, so please do not. I repeat, it doesn't work. I repeat, do not submit JavaDoc files. I don't want to have web pages and web pages and web pages delivered to the submit system. Just submit your code, okay? But do use that style of commenting to make sure that your code is clear and concise. And take your time to choose descriptive names, use for comments and for methods. It makes a huge difference. Now, verbose, meaning overdoing it, repetitive code, often causes confusion as to what your code's doing. So keep your code concise, your definition simple, clear and short. And that's pretty much it. So we'll call it a day there. Now, we have a week off next week, don't we? Isn't it? Yeah. Okay, so I'll see you guys in 2 weeks' time. Yeah. Any questions, just let me know, and I'll do my best to answer them as much as I can. Thank you, guys.